Okay, so number 11, square root of 99. That is the same thing as the square root of 9 times the square root of 11. What you want to do when you're doing these problems is try to break them down into the largest perfect square that you can think of. It's kind of like a factor tree. And then take the square root of what you know, try to break down what's left over, and go from there. So I know that the square root of 9 is 3. I know that 11 is prime, and I cannot break it down anymore. And 11 is also not a perfect square. So we will leave it as square root of 11. So your final answer is just 3 radical 11. Let's try one that is much more difficult than that, and that would be number 19. This one not only has a negative number in front of the radical, but now there's a variable underneath it as well. Remember, that's called the radicand. So I'm going to start by writing the negative 21 because it's just hanging out there. It's not doing anything so far. I'm going to break down 27 into 9 times 3 times x to the 8th times another x. The reason for that is because you can think of variables like shoes. So if I have 8 here, that would be 8 shoes, which all can be paired up. If I just have one shoe, then that means it doesn't have a pair. We're not taking the square root of 8. We're trying to break up 8 x's into pairs. So what you do is now start taking the square root of everything that you can and writing it on the outside. So I know that the square root of 9 is 3. The square root of 3 is a prime number and doesn't have is not a perfect square, so I can't take the square root of that. If I am looking at x to the 8th and I had 8 shoes in front of me, assuming that they all had a match, that would be 4 pairs of shoes. And if I have one shoe in front of me, then there's no way that has a pair right in front of me. It doesn't have a match. So here is what I could take the square root of. And I'm going to write down what I couldn't take the square root of, which was 3 and the x. And that looks really ugly, so we always need to clean it up when we're done. Just combine what you can. So I know that negative 21 times 3 is negative 63. I can scooch that x to the 4th over, and 3 times x can just be written as 3x. So the way you would say your final answer is negative 63x to the 4th times the radical 3x, or you could say times the square root of 3x. In the next section below, starting with number 23, you are being asked to multiply radicals together. So if you look at 23, we've got a 1/3 that's on the outside of the radical sign. So I'm going to write it down. Can't do anything with it yet. And then for the square root of 6 times the square root of 24, I'm going to write one radical sign. I'm going to keep the 6 and not break it down. And that's because I know that 24 can be broken down into 6 times 4. And remember, when we're doing square roots, we're looking for pairs of things. It's something times itself. Well, you've got something times itself right there already. So I'm going to break down 24 into 6 times 4 for that reason. So I'm going to copy the 1/3 again. And I have a pair of 6s, which I will bring out to the outside. And I also know that the square root of 4 is 2. It's a pair of 2s. So I'm going to bring that to the outside as well. So now I have 1/3 times 12. And 1/3 times 12 is the same thing as 12 divided by 3. So my final answer is a nice and pretty 4 with no radical signs at all, just the answer 4. Most of your answers today will have radicals in them, but sometimes they do not. In the bottom section, you're being asked to divide your radicals instead of multiplying them. So the concept is the same as the previous example. The only difference is that sometimes you're going to have to do a little bit more work just because of the rules of math. So for instance, if you're doing 39, you have a nice perfect square on the bottom. Square root of 64 would be 8. Square root of x squared would be x. So if you had that kind of problem, you'd be okay. But the rule is that you cannot leave a radical in the denominator of your fraction. So if you look at 43, unfortunately, we have a radical 8x. Neither one of those are a square number. So we're going to have to do a little bit of extra work. In the numerator, we have radical 5. So that's okay the way it is. In the denominator, I'm going to change the radical 8x into square root of 4 and square root of 2x. So I know that the square root of 4 is 2. And I'm going to recopy the other items. So here's how you simplify a problem and clean it up. I mean, that is a correct answer, the way I have it. It's just not acceptable to leave it that way in math. So when you have a radical that you can't do anything with, to change it, you multiply it by itself. Because remember, we're looking for pairs of things. So if I already have square root of 2x, if I multiply it by another square root of 2x, that will make it something that I can take the square root of. And you should know by now in math, if you do something one place, you got to do it somewhere else. So if we had it in the denominator, I now need to put it in the numerator to balance my problem out. I'm not allowed to change the problem, and I changed it by putting a radical 2x. So to balance it out, I put it on the top as well. So let's do our final cleanup. In the numerator, we have radical 5 and radical 2x, which would make radical 10x. In the denominator, I have a 2, and I have a pair of radical 2x's. So the square root of 2x times the square root of 2x is just 2x. I have a pair of 2x's. Final cleanup is radical 10x in the numerator, 4x, because that's what 2 times 2x is, in the denominator, and you are finished. Do not try to simplify this any further. If you have a radical like you do here, and you don't have a radical like in the denominator, you're not allowed to simplify those and tell me that the final answer can be divided by 2 and that you can cross the x's out. You're not allowed to do that. You are done. It's radical 10x in the numerator and 4x in the denominator.